Good morning, good morning. It is August 11th, 2019, and we have a special update. We're going to talk about sciencey stuff. So let's throw up the API Master Test Kit card and talk about all that sciencey stuff up on the screen. So first you see that this document is called our tank log, and we've actually pulled up the full screen of the notebook that you guys have seen forever and ever. And so we're going to talk about water parameters, and the first thing you see up there is pH. pH is a measurement of how acidic or how base your water is. So think of vinegar is acidic, and it would be on the lower end of the scale, and baking soda is on the higher end of the scale. So as you can see, 7 is neutral, and so we're going to ignore that column that goes from sort of a butterscotch color down to purple. That is the high end of pH, and for most of us, that's not going to come into play. So the third column down is your total dissolved NH3 and NH4 or ammonia. And ammonia is, what's excreted in urine, and it's good fertilizer for the plants. It's also can be excreted in a little more concentrated form in fish poop as well. And that is a good thing to have to fertilize your plants, but not in excess. Now, the column that starts with the blue square, so the second from the right, and goes down to purple are your nitrites, or NO2. And that is the chemical that's created when ammonia is being converted by bacteria in the nitrogen cycle. And then finally on the far right we have the nitrate column. It goes from like a sunny yellow down to sort of a burnt orange. And that's the last step in the nitrogen cycle, and nitrates are not as detrimental to fish and livestock as nitrites and ammonia are. So next we're going to take a look at the little kit itself. You can see you have several bottles that are different test solutions. You have 4 test tubes to make your water tests, and the little cards that indicate what the color of your test solution means. Now, we showed you the master card. It depends on, I guess, where you get your kit. If APR gives you a big master card like we showed in the beginning, or if they give you the little individual cards. Next, we're going to show you a sample test where somebody ran a test on their water and the results that they got. So our pH is just below neutral, coming in at 6.8. The total dissolved ammonia, both NH3 and NH4, is coming in at roughly 25 parts per million. The nitrites or the NO2 are coming in way at the end of the scale at 5 parts per million, and the nitrates or NO3 are coming in just above the end of the scale at between 40 and 80 parts per million. I'm going to call it 60 parts per million. Awesome, you say. So what are you telling us? It's just a bunch of colors. Well, what I see in this test result is that pH is within normal range. It's fine. The ammonia is coming down relative to the increasing value of the other tests. Well, you may say to me, well, how do you know that? What do you mean by increasing values in the tests? Let's look at a different set of test tubes. On the left is freshwater nitrites, and on the right is freshwater ammonia. So you can see that in these two test tubes, they're testing the ammonia and the nitrites, which are the sort of first and second in the order we saw on the cards, and that the ammonia is at 0 parts per million, and so are the nitrites. So here's that first card again, and you can see that the ammonia level is starting to get paler and paler, while the purple one, the nitrites, is getting darker and darker, and the orange one, the nitrates, is also in the dark end of the scale. This gives you a visual representation of what the cycling of a tank looks chemically. So ideally, your ammonia, both NH3 and NH4, should read up in the third column, the middle column, it should read 0 parts per million. The nitrites, the next one on the right, the NO2 should read 0 parts per million. And the last column, the nitrates, should read less than 50 parts per million. I like to keep mine less than 30 parts per million because I have a very small tank. I should also point out that the volume of water in your tank makes a difference in how much nitrate and nitrite you can tolerate. So someone like me who has a 3-gallon tank, I really don't want to see 30 parts per million in my nitrates, but I'll tolerate it temporarily because I can usually fix it with a water change. Somebody with a 20-gallon long might be able to get away with 50 parts per million and doing a partial water change to correct that. Well, you also say to me, clearly those weren't your tests, so put your money where your mouth is and show us your tests. All right, let's do that. Let's put up our chart, our little cheat sheet that tells us what our water parameters need to be generally to keep fresh water. Ammonia, 0 parts per million. Nitrites, 0 parts per million. Nitrates, 30 parts per million. And pH, for fresh water, 6.5 to 7.5 pH. So here are my test strips. On the far left is the test strip that was fresh tap water, just poured into a little jar, and the test strip was dipped. Next to it is tank water that has been stationary for 2 weeks because we have no artificial filtering, and it has, the soil, the pebbles, and the plants that you've seen already, but no livestock. So looking at these test strips, which are almost exactly the same, do you guys notice a problem? Let me tell you, I sure do, and I was very surprised. Remember, we have not used an artificial formula of adding ammonia to cycle this tank. It has only been water changes weekly, and our results really surprised me. I know in this state we have hard water. When I lived in the city, we used to laugh and say you could pound nails with our water. Well, according to this, the water up here in the hinterlands, you could actually build a house with, which I might need if I want a bigger aquarium, but that's another story. So let's look at the industry standards for the 4 major divisions of shrimp. We have Caridina, we have bee shrimp, we have Neocaridina, and Sulawesi shrimp. And Amanos are not specifically listed here, but they are part of the Caridina family. And because they're Caridina, they are not suited for this tank That poses a big problem because I wanted a mono specifically for algae cleanup. But let's move on. Let's look at the chart and see what it says. My pH is 8.4, which is way too alkaline for all of these shrimp except one, maybe. My GH is 300, and that measures softness to hardness. My KH is 300 parts per million, and that measures alkalinity. We've already established that it is very, very alkaline water. My NH3 and 4, or my ammonia, are 0. My nitrites are 0, and my nitrates are about 20 parts per million. It's really hard to tell on that strip. And that's the last one with the sort of white to hot pink on the top. So as you can see, when you look at the water parameters for industry standards for these 4 types of shrimps, the only one that qualifies or could maybe work in these water parameters are Sulawesi shrimp. I'll tell you right now, I have never raised them and don't know anything about them. That being said, there's no reason why I can't learn about these shrimp, but I'm really going to have to think about this. So on the right, you see we have a mixed bunch of reds and looks like maybe blacks or charcoal colors, and on the right we have the cardinal variety of Sulawesi. And I have to say, the cardinal variety of Sulawesi is every bit as pretty and intensely colored as any Cardina or Neocardina. So they're not ugly shrimp by any means at all. So what can be done about this as far as making it suitable for other types of shrimp? You can buffer the water by using either Indian almond leaves, or you can replace the substrate with a majority of peat that will turn it into what's called a black water tank. You can also use wood or a combination of those to acidify the tank, but none of them are really good solutions. The other solution is that we could use RO water, which is the purest mineral deposit-wise, the purest form of chemical filtration in the industry, but then we would have to remineralize by adding calcium supplements and other supplements, and that just does not, in a little white box apartment, seem like a reasonable thing to do. So where are we at today? Well, we're going to throw up some tank shots. This is yesterday. I am going to tell you before you go into shock, I cut that dwarf lily down tremendously, and the reason being I want that dwarf lily to keep producing leaves for the time being. I do not want it to flower, and when it hits the surface, enough of it, it will flower. And as you can see, the new leaves on this plant are starting to curl the way I want them to, but there has been a really big volume of melt or yellowing and dying off, and I think that has to do in part with the water parameters. And as you can see, this green plant in the foreground is a cryptocoine. I don't know if it is the lutea, which I've raised before, or if it's the lucens, but it is rooted and I'm not touching it because it's doing fine. And this might look like a pile of rocks, but it's not. In the center of that highlight is our big mama, big papa snail with a couple of babies hanging on. It has flipped itself over overnight and is either resting or getting a little snack off the pebbles in the substrate. We're going to leave it alone. Snails are hermaphrodites. We're not going to talk about that, except to say that that snail, should it remain healthy, will breed new snails, and I hope they are that pale green cream color. So here's one last shot of the trumpet snails climbing up the side this morning. I hope you enjoyed this. I hope you learned something. I hope you have a great weekend. God bless you. For me and the shepherd and the Malaysian trumpet snails, we'll see you soon.